This is going to be part 2 of installing my geothermal system. So there is the unit. That's a water-to-water system, meaning that this is the ground source loop. So I have a loop in the pond that comes in and out right here, goes into a flow center, which is where the pumps are that pump the water through the loops, and it pumps it through the system. So if you don't know how geothermal systems work, they work just like a refrigerator or an air conditioner. They don't create heat, they move heat. And they also do cooling, so again, they don't create the cooling, they move it. So basically on this side of the system, the loop comes in and out of the pond, and it circulates around, and this unit will extract the heat from it. So if I got 50 degrees coming in from the pond, it'll extract that, and I don't know what it'll go back out to the pond at, but it'll probably be around freezing. So there's going to be an antifreeze solution in the line to keep it from freezing. And that's why all these pipes going into the loop and out of the loop are insulated, because they will condense and then you'll have condensation. So just like an air conditioner creates cool air out of the hot air that surrounds it, this does the same thing, except the medium that it uses is not air, it's water going through the earth. So they also make geothermal systems that are water to air, which it will take the same thing here and have water going through the earth, but on the other side, instead of having more pipes to go through your house with hydronics, it will have an air handler and it'll have ductwork. The nice thing about those units is it's a lot easier to cool with it because you already have a duct, so all you have to do is keep that duct insulated, and then you have cooling in your house. So if you already have a forced air unit in your house and you want to replace it with geothermal, well, the water to air is a good option because it's basically like plug and play. You just sort of hook it up to your old system and it uses the existing ductwork. But since I'm starting from new here, I created a system that's going to use loops in the floor for my heating on every floor, and it's zoned out for each room. And then I'm going to use fan coils for my cooling, and I explained all that in the last video. So we got a whole bunch of parts and pieces here to hook this up, and this is only about half, maybe not even half of what I need to put in there. So this is all the electrical stuff that I need to hook the unit up. So on the load side of the geothermal system, this is what goes throughout your house. This connects to that manifold, and I have a domestic hot water tank. So I'm going to use the geothermal system to heat my hot water for the house, my domestic hot water. In other words, for showers and dishes and stuff like that. So that's a 80-gallon storage tank, and it's got a coil in it. Actually, it's got 2 coils in it. And so you're going to send hot water through these coils, and it's going to heat up this water. So it's much more efficient than any other kind of way that you can heat this water. This is a 120-gallon buffer tank. So when the unit turns on, it's going to heat up this tank. It's going to keep circulating around in the tank until it's heated up. That's going to be the hot water that's also connected to my radiant heat manifold. And in the summertime, that's going to be cool water in there. And it's just going to be a storage tank for cool water, and that's going to be for my air conditioning, 120 gallons. So that way, that unit doesn't have to run every time something calls for heat or cooling. This buffer tank will store the hot or cool water in it, so that when something calls for heat or cooling, the only thing that's running is going to be a circulator pump, which in this case I don't have it installed yet. It's going to be right here. So if you're following me so far, I hope I explained it simple enough. It's not super complicated, but it's not super easy either. Now this is something that you've probably never seen before because nobody does this. Nobody heats hot water with geothermal units unless they use a desuperheater, which I also do have here. These ports here are 1/2-inch NPT ports. There's one right here and one right here. That's a desuperheater, and what that does is when you're in cooling mode, it takes the heat, the excess heat that it generates, and it uses that to heat your domestic hot water, which you need another pump to do that, which I'll get into that later. But that's the common way to heat your water with a geothermal system. The problem is, in the winter time, it doesn't really work that well because you're heating. So it's not creating excess heat. It's actually creating excess cooling. Eric will be here tomorrow, and he's the genius behind doing this. But basically what we did is you put a 3-way valve on here, and That's this right here. This controls it. And basically, when that tank is calling for heat, which there's going to be an aquastat on it, so when it goes below a certain temperature, that aquastat sends a signal to this unit. Actually, this unit right here, it sends a signal to this, and it switches from this one to this one. This right here is for the buffer tank, and this right here is for the domestic hot water. And with the domestic hot water, you always want to set that as priority. The heat can wait, but this is priority when that flips on. So when this unit flips this little valve, it shuts that off and turns this on. So I have this whole thing configured just temporarily. Nothing has any thread sealant on it. Nothing is in. It's just sort of temporarily sitting here, just because I want to get an idea of where I'm going to be with different things. So there's actually 4 different pumps that are involved in this system. There's 2 on the flow center that goes in and out of the loop, sends it through this side of the unit, just keeps circulating around. And then this pump right here sends this water to the buffer tank, and that circulates around in it. And then out of that buffer tank will be some 1-inch PEX that goes over to that manifold, and there will be another pump right there which circulates that through all the radiant loops, which that's a much smaller pump and it's much more efficient. That pump only needs to run when the buffer tank is getting heated up. The other one there runs when any of those radiant loops turn on, and it's an ECM pump. So to give you an idea of the power input to this system will obviously heat my whole house easily. It's kind of overkill. Actually, it's a 3-ton system. Actually, it's almost 3.5 ton. And the running load amps is 20. So after this turns on, after the first few seconds, this will be at 20 amps at 240 volts. And that heats the whole house. And that obviously doesn't run the whole day. That only runs for a little while it heats the buffer tank, and then it shuts off. So that's extremely low power consumption. Basically, if you were to heat your house with electric heating, which in this case I actually did for a little while, I was using one of these tankless heaters to heat it with. The one I was using used 30 amps at 240 volts. Basically, with this system, for every 1 unit that you would use on that electric system, you would get 4 units of heat out of this. So you're getting like 400% what you would normally get. So in theory, your bill should be about 25% of what it would normally be if you were using electric to heat your house. So to compare that to any kind of fossil fuel, it's hard because the prices fluctuate all the time. Sometimes electric's up and fossil fuels are down. Sometimes fossil fuels are up and electric is down. But anyways, that's the overview to this system. So let's get hooking up some parts. I need to disassemble all that. But the first thing I'm actually going to do, because I'm not 100% sure that that's exactly how I want it there, the first thing I'm going to do is hook up these tanks, and then I'll get them piped over and next to the system with all the pipes. And then from there, I'm going to hook the electric up to everything that needs to be electrically hooked up. And then we can hook up the radiant heat, the pump, and the expansion tank and all that stuff that's going to be there. We'll hook all that up. Tomorrow Eric is going to be here. He's the genius behind this whole thing. So he'll kind of look over everything that I'm doing, make suggestions of how to change little things here and there, and then we'll get this hooked up finally. This is 1-inch threaded ports here. So every threaded connection that I'm going to do the belt and suspenders approach, which most professional plumbers will do, which is use tape first and then use pipe dope. And this mega tape is thicker than normal tape, so you don't have to wrap it as many times. Okay, so that definitely wasn't as easy as I thought it would be because all these fittings need to be so close to each other. I had this tilted, perfectly plumb before, and it made this so short that when I put the expander in there, it broke this elbow, so I had to redo that joint. And now this piece is like cocked that way a little bit, that piece is cocked that way a little bit, so it's got a little bit of an arch to it, but that's the only way it can really work. I was gonna come out of this with a street 90 and then go up and around so it was closer to the unit, but that puts these even closer together, and that's why I couldn't just come out and over, because you can see the way that they are. If I had tried to go like that, it would have been like this. So that's why I brought it out and up and then over, so that I could swivel back to make this straight here. But if I had used a street 90 coming out, then these would have been even closer to each other, because back at the unit they're like 8 inches apart. Out here they're like 10 inches apart. So I would have had even less room for these joints for here. So this is like bare minimum of what I need, and it sticks out like 6 or 7 inches from the unit, but you know what? It doesn't even stick out as much as this tank does without anything on it, so I'm good with that. So I got to do the same exact thing to the bottom. Alright, so we got all the loop side hooked up. Everything is tied in to the ground source loop, which is in the pond. So now this is ready to receive the flush cart. But we're going to work on doing the load side right now, getting that all hooked up officially. So I got to run to the store, but I'm going to leave this camera here while the guys work on it. So in order to take these plugs out, this is a 3/4 drive, just like you would use on a big truck. They're usually pretty hard to get out too. Not want to come out of there. I'm gonna have to use a braking bar on this.
Dad.
What?
Dad. He never said with the laptop. It's my laptop, and he never said.
Yeah.
Yeah. Now it's for sale. So I want the laptop really bad.
Yeah.
Yeah.
Why don't you ask him nicely?
No. He would say no when I asked. Blah, blah. Can I play with you too? Play with you too? Play with you. This is there more in it and some fish? Yeah, he not let me have the thing. Let's go see it in there.
So instead of coming out of there with that and then elbowing up with the pecs, I'm just going to come out with a street 90 instead. So I just got to change that up real quick, and then I'll go in from the top like this. That way it doesn't stick so far out into the room. The other one down there is turned more that way, so I can do that because I only have one of these right now. And just so you guys know, all these fittings that you see, that looks like galvanized, but that's not. That's stainless steel. So that's stainless steel, that's stainless steel, that's brass. Everything that you see is stainless steel. It's not galvanized. I know it looks like galvanized, but it's not. You need to use either stainless steel or brass. You can use black iron, but since I'm cooling, we found that black iron, if it sweats even just the littlest bit, it forms rust on the outside, and then it drips down everywhere, and it's not very pleasant. It still works fine though, because as long as there's no oxygen in the system, black iron works fine. Which that's the whole point of using all this HE PEX. This is for heat, and it's an oxygen barrier PEX. So once the oxygen is out of the system, when it first commissions, there should never be any more oxygen, which is what will make the black iron corrode. But because I'm doing cooling with this, I'm just going to go with all stainless or brass. And just so you guys know, when you buy fittings that are for like pipe thread, stainless is much cheaper than brass. But when you go to PEX fittings, brass is much cheaper than stainless. I think we figured out because it's the supply and demand, because there's not much of a demand for stainless fittings, so therefore the brass ones just end up being cheaper. That's the only thing we can come up with that makes sense. So we're gonna do a little experiment here. Remember how I said if these fittings are too close together, when you expand one side, you'll hit the fitting on the other side and break it? I don't know what will happen if you use brass, but something will break eventually, I guess. But I heard today that if you make the piece just long enough to fit the couplers together, and the piece of PEX that you connect them with is really short, I guess what you can do is expand the whole piece and put both fittings on at once. So I want to try that here because I want it as short as possible so it's not sticking out into the doorway here. Well, here goes nothing. I don't see this working. No, I don't see that working. Let me take that off. Well, it was worth a try anyways. I guess I lost an elbow and a couple sleeves, but oh, I got that one back. All right. But I can take this off eventually, but I got enough elbows, so I'm just going to start over. I'm not going to do that again. Really, you want it to be about 4 inches long. It's about the minimum you can get away with. I think I made it work with 3.5 inches, but 4 inches is a little bit safer. It's kind of important to be square in your cut too. Well, maybe that sleeve doesn't work anymore. I don't know. I guess not. I know it's not worth taking a chance though. You want about at least 2 inches between them. I probably could have made that a little bit shorter so it's not in the doorway, because it's about 1 inch into this doorway. But by the time you put a door on with the jamb and the space to shim it, it should be fine. I wish I had another street elbow for that, but it'll be fine. I'm not worried about it. So now all I gotta do is tie that into that right there. There's a T right there, and that's the return back to the unit. And then all this is piped in. Then all we need to do is go to the load side of this buffer tank and send it over to the radiant heat. So now that the buffer tank and the domestic hot water tank are hooked up, we're going to go ahead and hook up this manifold. And we're going to hook up the expansion tank, purge valve, fill valve, backflow preventer. It's all going to go right here. So normally you'd need to mount something here to hold the tank and the purge valve and all the stuff, the air scoop and everything. You'd frame something out of a couple 2x4s and then hang everything from that. But I actually just found this, and this seems to simplify everything and make it look a lot nicer. So this is a wall mount expansion tank holder. So basically you just mount it like that before the system, and then you just start hooking up all the different components to it. And it already has an air purge valve on it, but we're also going to have another one on it too. So when I was dressing this up on the wall, I realized that you can't put it on without having this air scoop on first, because the air scoop needs to spin around to thread on. So while that's on the wall, there's not enough room to do that. So we'll just put all our Teflon and pipe dope on and tighten everything down before we put it on the wall. But just to give you an idea, you got the hood scoop up there, air vent up there. Then we're going to come down with a street 90. This is going to be our fill valve. That's going to go on there like that. And that's a fill valve as well as a backflow preventer. So in other words, that fills the system with water, and it's an automatic fill valve. So you set it at whatever pressure you want and you just leave it alone, and it automatically fills depending on how much it needs for that pressure. I had it set on 14 before. I'll probably just stick with that. And also it makes it so that the water can't go back into your regular house water right here. That's the backflow preventer. That way, if you lose pressure in this line for some reason, this isn't going to backfeed. And so I guess it's kind of like a check valve in a way. Because otherwise you could end up contaminating your water system, and then you could actually end up drinking that water, which would be no good. And it's especially important when you have antifreeze in the system. So then our expansion tank goes right here. We got another air purge valve right there, which will actually be the 4th air purge valve that we have in the system. And then we'll put a gauge right here. So that's what I got so far. The only thing I don't like is the fact that that gauge is back here, which I guess I can rotate that. Alright, so now we got the gauge right there. So it's still hidden behind, but I guess it's not too big of a deal, because I don't even really care about that. I'm going to have a real gauge right here, and that's front and center, so that's fine. This is where you adjust the pressure, but once I adjust that, it's just going to stay like that, so I don't need to get back there. So we got air purge valve, we got fill valve, that could be a drain valve too, but I put it up here to be a fill valve just in case I want to put glycol in here, which I may do, I'm not sure. Got the pump, got our flange, and now we just need to make it from there, go over and down into my radiant loop. Now I'm going to have to use 3 elbows here, but I don't really have much of a choice. The only other choice would be to move this over and move that over, but neither one of those can happen. So the nice thing about this expansion PEX is that the fittings are the same diameter as the pipe. So the inside of that fitting is the same size as the pipe. So that'll gain us some flow when using elbows. It's still not a great idea to use elbows unless you have to, but in this case we kind of have to. Now off of this supply to the manifold, we also need to tee off and go to our fan coils upstairs. So everything is hooked up here except for hooking up my actuators here and tying them into the controller. And then I just need to hook this up to my cold water supply, and then everything should be ready to fill. So the one last thing I need to work on here, that loop comes out for my fan coils, and I got a T into here for the return to go to my fan coils. So I'm going to have a little setup on this wall, and there's going to be one zone valve to control my downstairs first floor fan coil, and then the other one is going to be 3/4 going up to my attic, which is going to control a separate manifold for my 3 fan coils up there. Alright, so I know that looks crazy, but this is the supply coming in. That's for my first floor fan coil. That's for my second floor manifold, which that's going to have thermal actuators in it, so I don't need a valve on there because the thermal actuators will actually be the valve. They're just upstairs. So then out from here, I go behind the wall, go upstairs to the first floor with the supply, and then this is the return from the first floor. And then from the manifold upstairs, there's the return to that. So those tie together. That gets teed into the return for the system. So that's all looped in. And I don't know, it doesn't look the best, but it'll work. So the one thing I need to work on is insulating all this stuff. Actually, everything needs to be insulated. Except for going to this tank. We don't really need to, but I probably will anyways. I have tons of insulation there. I have enough to do everything, but right now you guys know I'm in a time crunch. You know that I'm trying to build a garage right now, and I got to get the stucco done on my house, so I'm just trying to do bare minimum for right now. That doesn't need to be insulated. Nothing needs to be insulated right now except for the incoming loops for the geothermal system. That's the ground loop, because that's going to be really cold, so it's going to have condensation on it. So that needs to be insulated, but really nothing else does. It would probably run a little bit more efficiently if I did, but not enough to be worth doing right now, because it would probably be like most of a day to insulate all this stuff to do it properly and to look good anyways. So I wanted to do a few loops going like that, but I figured it'd be harder to insulate to do that, so I just left these with elbows. I know there's going to be a lot of people that are going to pick that apart and say that's going to reduce the flow a lot, and I agree with that, but with these opener fittings, the fittings are just as big on the inside diameter as the pipe is itself. So the only flow restriction is going to be in the fact that it's an elbow or a T. It's not like the crimp style fittings where the actual fitting fits inside of the pipe and then it's reduced, plus you have the resistance of the fitting itself. This is a lot better. So I was going to come off the 1 inch and go to 3/4 and then hit the manifold upstairs with that, and then branch off to the 3/4 and hit the 1/2 inch for the first floor. But I decided, let's run the 1/2 inch right off the 1 inch. That way, the first floor is gonna need quite a bit for 1/2 inch pecs. It's probably gonna be maxing out the flow for that to get that, because that's an entire floor being controlled with one fan coil. So 1/2 inch is probably bare minimum for that. So I didn't want to split that off the 3/4, because then we're splitting that between the upstairs and downstairs all off a 3/4, which probably would have been fine, but it was easy enough to just run it back off the 1 inch. That way, again, my flow restrictions are a lot less because I'm going from 1 inch instead of 3/4. So if you stand back and look at everything, it doesn't look like a professional did this. Honestly, I could do a lot better, but right now I just want to get things done, and this is my house, so it's not like I'm doing it for a customer. There's nothing about this that looks that great, except for the work that the guys did. You know, they did nice, clean work, but everything that I've done doesn't look exactly like a professional did it, but I'm not a professional, so I think that's fine. So the few things that we have left to do, and I can start purging the system in the meantime, but I need to hook up my domestic water. This is where the hot water comes out of this domestic tank, goes right into this manifold right here. I'll just tie in right there. And then I need to supply it with a 3/4 inch PEX going all the way to my cold supply right here, which I'm just going to tee off right here because these are 1/2 inch. So those need to be done. I need to hook up that pump, give it some electric. That pump I need to give electric. And that pump I need to give electric from this controller. And I need to hook up this supply line so that I can fill the system. But really, that's the first thing I'm going to do, because then I can get filling this system, because we need to fill it a lot. It's going to take a long time. We got 120 gallons in there, plus we got 100 feet of 1 inch PEX, which I think is only like 3 gallons itself, but then we got various other things going upstairs, so probably 10 to 15 gallons between all the extra stuff, and then we got 120 gallons there, plus we got all the radiant loops for all 3 floors. So there's a lot to fill up here. And Eric and his crew are going to come by tomorrow, and they are going to flush this part of it. This is where they hook the flush cart to. That gets all the contaminants out. He's got a filter that does that, and then he's going to fill this up so that the ground loop is filled up, and then we can fire the system. But in the meantime, if I can get all the air out of the system and get everything tidied up so that they can just do the flush part and the fill part, then we could have heat by tomorrow night. Also, one more thing to note before I fill this system up, I need to put some ball valves in. I wasn't exactly sure where I wanted to put them yet, but I should do that before I fill up the system. I think I'll probably put 2 right there, probably 2 right there, and then I'll probably put 2 right there to isolate that whole thing. And I think that should be good. I only have 2 right now, so I need 4 more. I gotta find them before I fill this system. Alright, so there is one more thing I need to do. I made a mistake here. When I put this tank in, I saw these little blue rings on the top of these ports, and I thought that they were plugs. So what happened is, I put this in here, and I started doing work over top of it, and I know I got some debris inside of those ports. There's 4 different ports here. You can either do 3/4 or 1 inch, and all 4 of those were open. So I'm sure that I got some debris in here, and that's not good. That means that that debris can get from there into the coils in here, which those coils are pretty small, so hopefully the pieces aren't too big. But also those pieces can get into the geo system, they can get into the loops, they can get into anything that's in there, and they can go all the way upstairs and all kinds of things. So what I want to do here, since this is the output of this tank, I'm going to put an inline filter. So this right here is a hot water filter. This is meant for hot water systems like this. It's not exactly meant for radiant heat, but it's meant for hot water. So it's got an 1.25 inch port on it, and I necked it down to 1 inch. So we're just going to hook this up inline. This has got a 100 micron filter, which that should be fine. We're going to hook this up inline. It's kind of got to be vertical like this, so we got to hook it up to a horizontal line. So the first place that line goes out and comes horizontal is right here. So maybe we'll put this like right here. That way it pretty much forces all those particles to go right into it before it hits anything else in the system. I may or may not keep this here, I'm not sure. I know you'll be like hitting your head on it and stuff, but I think once I get all the stuff filtered out, maybe I can turn it up to the side like this and then just sort of mount it up there, because I won't really need it after that. Or I can just take it out and put a coupler in there. It was a big mistake to do that, but this system is way too expensive and too much things going on to risk having all that stuff contaminate my system. So this was like little over $100 for this, and it just is needed at this point. Alright, so I've been double checking everything to make sure that nothing should leak. Hopefully it doesn't. There's lots and lots of connections here. I did shut off these going upstairs for right now, just because I want to do that separately. So we are ready to turn on the water here. So I'm going to turn this on. So we're starting to fill up here. I'm going to start checking for leaks. Look, you can see the water going. There it goes. Just going to start filling up this thing. Cool. And there it goes, and there it goes. I don't know if you guys can see that or not, but it's going. It's going right into the tank. There it is. Going into the tank. Now we got 120 gallons. So I'm gonna open this up. That should hopefully let some air out. Open that air valve. And you can actually hear it hissing. Open up this air valve. Okay, well, we'll get that later. We got these ones. They're open. That's open. Okay, this one needs to be opened. There that goes. See all the water's going in there. So now let's start filling up the loops. Oh, we got a leak. Yeah, kind of knew that would happen. Might have to put a piece of PEX in there with a cap on it or something, because yeah, let's shut that off. We'll get the tank filling for right now. I gotta just put some stubs in here, just because otherwise there's nothing stopping this water from coming out here. On the return here, you can turn these off, and that turns everything off, but I got this off, so it shouldn't be coming out, but they always do anyways. This pump is kind of cool because it tells you how many watts it's using and how many gallons per minute. It's on auto adapt right now. You can see it's pushing a lot of air out of these loops. What's nice is all the air that it's pushing out of these loops, it's sending on the return to this tank, and I have this T&P valve open, so all the air is coming out here much faster than any other air valve. So right now there's just massive amounts of air going into this tank, but it's going right out there. That's because it's not filled yet. It's probably somewhere in here. You got to think though, this tank, when it's full, 120 gallons, that's almost 1,000 pounds. Every time there's a rush of water, there's tons of air in front of it and behind it. Anybody that does hydronics for a living, like radiant heat type stuff, just watching the air get out of the system is so satisfying. I don't even do it for a living, but I just think it's so satisfying. Every little bit of air that's coming out, it's just like, that's great. Now it's starting to work on the upstairs loops, which is these 4 right here, which I knew would be last because that's going to be the hardest to push through because that's 2 floors up.
Lift up, lift up. Now he's all excited. Do it again. Just sit up straight though. Hang on. Let's give her a 2-second break.
Oh, wait.
new bag filters are coming today though.
You did order them? Don't leave it.
Pretty beefy motor on there.
Yeah.
It's a little dirty.
We started this one yesterday.
Oh, that's the bag filter you're talking about?
Yeah.
You want to loosen it a little bit, or? Oh, I guess
That's
you got it.
That seems like a pretty fine mesh on that.
Yeah.
What?
A big pan is coming.
A what?
I scraped myself on.
So we're gonna turn down now. Just want to make sure it doesn't suck in air. So keep it filling. We put the hose on the bottom to fill.
Residual. Probably in the filter too.
For some reason, it's making the most noise right here.
Yeah, it must be like water. Or,
Well, it's the first elbow.
It's the air coming up probably.
Yeah.
Today?
Hope not. I just want to make sure the water we're still good.
So the whole purpose of this flush cart is to get any contaminants out of the ground loop, which in this case it's a pond loop, but same thing. And it gets all the contaminants into this filter. And this is, I think it's 75 micron filter, so it gets some pretty small particles out of there. Because anytime you're cutting the pipe, you get little pieces of plastic. And even when you get the pipes from the factory, the way that they cut it, we think they use a chop saw, so you get contaminants in the pipe. Regardless if you got them in there or not, they're going to be in there. So it's important to always flush the system out with a flush cart before you run it, because otherwise it goes through the coils in there, which are a lot smaller than the pipe going in. This will also get all the air bubbles out, and it in general just fills up the system. Oh, is that like a special programmer that you have to,
tool, yeah.
only for installers?
Yeah.
Should I hit the breaker?
Yep, we can do that.
Christmas lights in there.
Oh, yeah.
That's cool that we didn't even have to wire up the Thermostat. I'm sure it's not that hard, but still. Oh, okay.
So you have to add. This is a communicating thermostat, so that's why it has to be added to the devices.
Yeah.
So here on this gives you an overview. So it's on standby right now because we don't have it on any call. And then FP1 is the ground loop. It's set for 30 degrees. And FP2 is the load side loop. That's set for also 30. RV is the reversing valve, so it's set for O. So O will activate the reversing valve when we get a call for that. And then these other ones are for other different
Water to air
tasks.
systems and stuff.
Yeah.
Yeah.
Yep.
So what's that 30 degrees on those two things? Is that a limit for something?
Yeah. So if FP1, which is the ground loop, hits 30 degrees, it'll shut off,
Okay.
and it's a safety thing.
Yeah.
When we put antifreeze in, it'll be 15 degrees.
Oh, okay. So you can set that manually
I can
once we
set
put
it
the.
on the dip switch in here.
Yeah.
So like, see this right here? If I flip this dip switch,
Yeah.
see now it changed to 15 degrees.
Okay. That's cool.
But that's when we put the antifreeze in.
Yeah.
And then there's test mode. So if you don't want to wait for the delays, I can hit test mode, and then it'll speed up. Like, I think it speeds it up like 3 times or something. Or no, maybe it's, I don't know if it is. Yeah, 3 times or so. I think that's what it is. So now what we can do is we can hit this. So right now the tank's at 64 degrees. You're entering low water temperature, which is inside here, is also 64. And then we can hit this, hit the middle, go to heat, and turn that on. Then I'll turn the pump on, as you heard the pump come on.
Yep.
So what it does like a pump cycling, sampling, I mean, where it'll try to see it flow from the tank into the coaxial to see if it is, the temperature of the tank is similar to where it pulls it in.
Does it check the pressure too? Like if it's too high pressure, then it senses that before it even turns the unit on?
I mean the refrigerant pressure?
The like, remember you talking about the pressure going into that tank was too high with the.
That it doesn't have anything to do that. But if it is, the refrigerant pressure is too high or too low, it won't do anything.
Oh, okay. So what's that? If that is that the refrigerant pressure that you're talking about with that tank? If you don't have the 2 loops, if you don't have the 2 coils hooked up,
Yeah.
the refrigerant pressure is what gets high.
Yeah. Yep.
Okay.
Because it can't take the heat out quick enough.
Oh, okay. I thought it was the actual pressure of the load side.
Right.
Yeah, so it's the
refrigerant pressure. Yep.
okay.
And then here I can see, well, there's refrigerant, so we can see all the refrigerant.
Yeah.
But nothing's running right now, so it's equalized. You can see how much energy everything uses, but nothing's really running except the load pump is drawing 135 watts.
Oh, nice. That's kind of cool. Can you see that on the Symphony too?
Yes.
You can see all that, the different
Yeah,
things
you
in
can see
there?
yep.
That's awesome.
So you'll be able to see that.
Definitely need to.
I got it. I brought it in, and then the performance, right? You know, it's really like, that's just the calibration. It's a little off, but
Yeah.
it might even just be because one part where the sensors are, but will show the entering source and leaving source, and then and their water flow.
Nice.
You'll be able to see. So then, actually, I gotta add a sensor part.
What do you have to do to get signed up for an account like you have, or do you have to be an installer?
Yeah, to be installed. That's the bad part. If you ever ask me, like, engineers always want that information too, but
Yeah. Well, there's a lot less low-end noise than I thought when it starts up. It's probably.
so you'll be able to see, like, this is one of my customer sites. So you'll see the loop temperature. Of course, he has his in cooling mode. So he was just asking me about that today. So I think that's why he wants to zone his system.
Yeah.
So you'll see the loop and the leaving, the tank temperature, compressor is on or off and electric heat, which you'll have hook up. Then you'll be able to see all the power. So you'll be able to see compressor, load, loop, auxiliary,
Yeah, that's really
and
neat.
total capacity, energy. And then you'll see the tank set points. And then you can actually go to like the hydrostat, which is that.
Yeah.
And so you can change it from heating to cooling right from that.
Oh, so you can mess with people then.
Yeah, no, I can definitely.
They don't pay their bill, you just shut the heat off.
I could too, yep. And then, yeah, there's troubleshooting. I don't know. I'm not sure. Like, I got the A tool, but I don't think you can do the A tool on your end. But like, just like this is the A tool, I can do that remotely. Oops, what happened? High pressure. Oh, we must have air bound in here.
Oh yeah. Oh well we're not even. I don't even have this cracked here. The tank here.
Oh, it wasn't open?
Yeah.
Oh, that could be why too.
Yeah.
Duh.
Everything else should be good. Those are open.
Actually, that should be a little bit more straight. But yeah, so like, this is where I can see that, that exact tool, I can see that remotely from any job. So I can really mess with people if I wanted to.
Yeah.
You know, so I just alerted.
Yeah, high pressure. It's high pressure. I forgot to open these valves. That was my fault. So now it just times out for a little bit.
Yeah, so actually, we didn't really bleed this one, did we? Either.
No.
We could probably. Shoot, you want to hose on there or something?
Do you want me to turn this side on? Would that help bleeding it too?
I might start to draw some fluid through, yeah.
So I can just turn it on for right here. I just turn on my heat and
Oh, right, from your phone.
the Ecobee.
Yeah. Let me see if I get it. Let me do this. Shoot. I don't know if we can get a hose on there though. I can try to open it and see if air comes out. Oh, yeah. Shoot, I did it too fast.
Hey, I'm not worried about water in here. Oh yeah, we're down to 5 psi now, so I'll turn the fill port back on.
Oh, maybe that too, yeah. Oh, we didn't burp this either. We were gonna jump in the gun. I hear the water phone. They're starting to flow. You have to actually, on these grunt fist pumps, you gotta burp this.
Oh.
Sounds like there's a layer in there.
Yeah, and I just heard my purge valve up here do something too. My plan was to try the cooling mode first, but
Oh, okay.
that was actually it wouldn't. I guess it wouldn't be a bad day to do that.
Well, you could do that. We could. Yep.
I was just like super curious to see about the fan coils. That's like the most complicated part, and
We can cool it easy.
yeah,
I just worry if this isn't getting flow, it'll freeze. But
yeah. Now, what kind of temperatures do you like running in the cooling mode?
oh shoot, this. I usually put the tank to 40.
40?
But you can play that if you want to.
Yeah.
I just do it for dehumidification. It's better.
Oh, so the lower the better for
Yeah.
dehumidification? Yeah. Now, I was also wondering, like, when I'm in cooling mode and we want to heat this tank, the domestic water, that I'm assuming it doesn't hurt anything to have like whatever's in the line left over from the cooling go straight into these coils.
No.
I mean, I guess we do have a few feet of PEX before it gets there, so it'll kind of tamper. What do you?
Like you might get a little bit of like just flow from that's left over. You mean the residual?
Yeah.
Yeah. Like whatever's in these pipes.
Yeah.
But that's all.
I guess
It'll warm it up pretty quick.
Well, I guess the only thing I was wondering about is if it like, because if the tank is kind of hot, if it shocks something and like, but there's really nothing that's like cast in there anyway. So
No, it's just copper pipe.
and the tank
Or
would,
stainless. I think that's stainless on that one.
and the tank would be at its lowest temperature anyways. So
Right.
so if it calls for heat, it would be at, you know, whatever the set point is, like 90 degrees or something, 100 degrees.
Right.
That's not that bad. 40 degrees to 90 degrees or 40 degrees to 100 degrees.
This is the symphony you can put in right here. And then, oops. So there, if that is solid, then you're connected to Wi-Fi, but I have to program this one, and that's just the status saying it's communicating to the unit.
More Christmas lights.
So you're drawing, compressor's drawing 10 amps.
Wow, 10 amps.
Yep.
Oh wait, no, but there's
Right.
2 compressors?
Oh, hold on, what's that? Oh. Yeah, it must be 18 amps then. I don't know why they do 2 compressors. And then the load pump's 0.7. So you're drawing a total of 25, 41.
2,500 watts?
Yep. With the pump, load pump, source pump, compressor.
Yeah, but wait, 2,500 watts. That's way lower than I would think, right? It's 20 amps.
So we're drawing 12.5 amps.
So the last thing I want to do is hook up this domestic hot water heater. So I just need to hook it up to this manifold. That's the supply line from the tank going into the manifold. And that's going to be the cold water going in. One of the downfalls of using expandable PEX is that if your local box store doesn't have stuff in stock, then you're kind of out of luck on the weekends and nights, because my local supplier that carries this stuff is only open 9 to 5 Monday through Friday. So after 5 and on the weekends you can't get any parts. So I didn't have a ball valve that was expandable PEX for 3/4, so I had to use the crimp fittings around it, which I looked it up and you can do that. Some people say that you can't do that. I don't know, maybe you can't with opener, but I know with this brand you can. I looked it up, so it should be fine. I mean, it looks weird, but it works, and I'm not gonna wait another day to get this stuff, because I don't know about you guys, but Monday through Friday 9 to 5 I'm doing super important stuff, and for me to go run to the store to get that little valve, it's just not necessary. I can do it on a weekend or night, and it's so much more efficient for me. So my local box store does carry expandable fittings, but every time I go there, the stock is just not updated. Like, they just don't care to update anything in there. Half the fittings are missing. So my local plumbing supply has everything I need, but like I said, they're only open 9 to 5. So I'm filling up the tank now. I got this T&P valve open, and remember, there's 80 gallons in there, so it's going to take a while. So for right now, we still need to hook up the controls right here, but for right now, I'm going to just manually turn this until we get those hooked up, because 80 gallons, I can heat that up with the geothermal system, and that'll probably last the whole day. So each day, I'll just open that valve, let it run through until it gets 110, and then I'll shut it off. And then in a few days, when we get the electronics hooked up to that 3-way valve into the geothermal unit, then we'll be all good to go. Alright, so I just manually turned on that three-way valve so that I can heat this tank. You can see we got hot water going in the top. And then that's our return down there, which is not nearly as hot. It's still warmer than the cold water coming in. There's nothing going out on the top, so that shouldn't really be doing anything. And we just filled that tank. So we'll shut this off. Now the tank is full. So it's been a while since I did any work in here, but I got to test this out for the last 2 weeks. Eric's going to be here in a little while, and we're going to do the final steps to complete this system, which is basically just hook up this three-way valve, because right now I'm switching it manually. So we're going to hook that up so it's all automated and hook it into the system. There's going to be an aquastat that hooks up to that, and also we are going to put antifreeze in the loops, because right now it's just straight water.
Okay, you ready?
Mm-hmm.
Welcome.
You're almost there, so be on. Daddy,
I only keep,
Yeah.
but they just do it so it's built into the head. Let's see how it works. See, I'm not gonna get it like totally straight. That's so. This is how you push it, and then you can turn it like manually, you know.
Okay.
Then, if you look here, that's the way the end switch is. S1, S2, S3, S1, S3, S2. So like normally open, normally closed, and which relay it is.
Yeah.
And then underneath this, you can do Y1 or Y2. You can switch that. So when there's a call, you have your negative and positive, but it's really 240 or 24 volt AC. But so this is, that's your common would be the negative, and your R is the one of the positive.
So the sensor goes in on this side?
There's no sensor on this part, but it's just, so I have
Oh, that goes to...
our box there, the Ranco. You can mount the tank, sensor goes in.
So that sensor
And then
gets
that-
wired to this.
So then when it gets a call, that's a relay too. That relay will tell the valve to move.
Okay.
And then what I do is I send through the end switch. So I wait till the valve moves to its position,
Okay.
then sends that signal over to the heat pump, a Y signal to turn on the heat pump.
Okay.
And then with the rib relay, I just have to disconnect the reversing valve so you're not cooling the tank,
Yeah.
and turn on the circulator pump, because the right now the hydrostat controls the circulator pump, so I have to actually control it, override that.
Okay.
So the blue wire that I'm sending your way
Yeah.
is the common. So that will go on the common on the
come over here.
Ranco,
There you
the
go.
negative on the three-way valve, and I think that's it. Yeah, that's it.
But that's cool.
No, you're not.
I'm looking at it. Oh, it's that one.
He just used one, yes.
Yep. See? Oh, there.
I just got hot tap.
What do you say?
I don't even know how he knows about that. He said he almost had a heart attack.
I thought said.
Go
I know it's
begin the tongue.
How's that working out for you, bub?
Come on, pipe. Let's do it, pipe.
We're gonna have to put a door on here with a lock, huh?
You are good. Wait.
So the R will power versus 24 volts
Okay.
there. So that has to go in there.
So that powers the aquastat?
Yep.
Okay.
That powers the aquastat. Okay, so you already put the blue wire in the common. So those two wires will power the aquastat.
Okay.
Then we got to do a jumper from the 24 volt or the red to the common on this relay, which is it's that one there. Yep. So it's that far one.
Okay. And that black one can stay in there too?
Actually, that one, black one will go to the common up here.
Oh, okay.
Yeah, so that will go to there. That powers the, if you see here it says number 1.
Yeah.
And number 1 is the negative, so that powers the valve, 3-way valve.
Oh, okay.
So that's the return path.
Okay.
It'll power it through 1 or 2 or 3, will turn the valve either direction, and then it returns like so back on the number 1, which is the common. So, just so you know what I'm trying to do, so we're sending it through this relay first, then the valve switches, sends it through this end switch,
Right.
then it'll send it over.
So the
turn on the
the
heat pump.
purpose of that is to not turn it on until this valve is actually turned?
Right,
Yeah. So this yellow goes to this red?
yes. And then when we activate it, we'll have to see if we have to switch this either direction, but
Okay.
just like I was telling, like, you never know which way. Sometimes it goes.
Yeah. And then these, so it would just be these 3 together?
Yeah. So that's the, so when we feed that, it'll send it through here. Goes to, one of those goes to activate the valve, the other one goes through the S1 to send it through the end switch, which then when the valve switches, it sends it to the end switch, sends it to Y. Y goes back to turn that on, and then it turns on all those relays. That's where it gets a little complicated.
Yeah.
Where I should just build the controller and patent it.
Yeah.
So this dip switch is for antifreeze. We gotta switch that dip switch.
Yeah, that's down to 15.
Switch to number 1, yep.
Yeah.
It'll be down to 15 degrees. And then I confirm on my here. So the ground loop's 48 or 49 and coming in, and it's 40, well, it's kind of jumping around a little bit, probably because it hit a hot spot. Probably the ground, coming in from the ground, is a little bit warmer than the pond.
Yeah.
And then we're running about 10 GPM. It has the antifreeze now. And so this is where, right now, going through your domestic hot water, it's coming into the unit at 72.9 and then leaving at 90.
Okay.
So that's your delta there.
And the heat of extraction is 45,000 BTUs? Oh, it's going down
Yeah,
quite a
it's
bit.
changing a little bit, but it's jumping around a little bit. I think it's picking up, I think because it hasn't been cycling through the unit, plus the antifreeze is kind of, we just put the antifreeze in, which is warmer than probably the loop.
Yeah.
So it didn't acclimate yet. So that's why it's all over the place.
So here it is the next night. Everything is officially hooked up. Now the hot water heater is fully automated. I don't have to do anything like manually switch it over, although I can if I want to. But this senses the temperature in the tank through this hole right here. There's a sensor in there. This is the controller for that. So right now it's at 111 degrees. And I can set this to whatever I want. I have it set for 110. And then this is the difference. So once it gets down to 102, it will click on, which will turn on this valve, turn it this way, and let the flow go into the tank. And when that actually turns all the way, then that will send a signal back to the unit to turn on. If that sent a signal right to the unit right away, the unit would turn on and the pump would turn on, and this valve takes a little while to turn, so then the pump would be deadheaded and it wouldn't be moving flow. So that's not good. So you want a little bit of a delay in it. So that's why there's an end switch, which will trigger the unit to turn on only after that valve is turned. So I guess I could demonstrate. So right now it's at 111. So let's set it at, guess we'd have to do like 120, right? Something like that. So that clicked on. Yeah, you can see that it's moving, but pretty slow. But that's okay. There's nothing wrong with it going slow. It's very similar to a valve over here. These valves do the same thing. They move really slow. So now the system is turning on. So now it's heating the tank. And remember, this takes priority over the regular heat. You always want the domestic water to be the priority. But anyways, let's set that back down, because that's a pretty high temperature. Set that back down to 110. So that turns off. That starts moving back, and then it shuts off the unit eventually. Right now the compressor just turned on, so it's not going to turn off right away. But what we can do, because right now the tank is at 83 degrees, which isn't quite the set point for it, so I have it set on 92, so we'll just put it at 96. That way it switches over. So instead of the compressor turning on just to show you what's going on over there when it didn't need to, rather than just shutting it off, I switched it to the tank. That way it heated up the tank and then shut the compressor off, because otherwise it's a waste, because turning on the compressor is kind of a big deal, so you don't want to just like turn it on and off all the time. So like I said, I know a lot of people do heat their domestic hot water with geothermal, but this is not a common way to do it. The de-superheater is the common way to do it, and that's those ports there. But in the cold season, this is a much better way to heat the water. I may venture into that when we're cooling, but we'll have to see how complicated it gets. So just to let you know, these are what's called thermal actuators, and basically there's some wax that melts in there and it expands or contracts to open up these valves. That's why it takes so long. And you can get you can get three different kinds. You can get 2-wire, 3-wire, or 4-wire. I just have 2-wire here because this is an ECM pump. So when the pump turns on, these are not going to be open yet, so it's just going to be having no flow. They call it deadheading. But this pump is fine with that. It will sense that there's no flow, and it will basically just sit there at a standby until it senses that the pressure is released, and then it can flow again. So these are all 2-wire, but I could have done 4-wire, and some people do that. And basically what that does is when you have a 4-wire actuator, 2 wires will go in on the left side here, and that's to open the valve. These 2 are actually like a sensor that it senses when it's actually open and makes these 2 closed, and it closes this circuit, which right now I have jumpers on all these. And so basically number 1 and 2 send a signal to the valve to open up, but then when the valve opens up, the valve sends a signal back to here, back to 3 and 4, and closes that circuit, which actually activates the pump. But in this case I have all 2-wire actuators, so I have a jumper in 3 and 4 on all of these. And like I said, the purpose is so that you don't run the pump without any flow available, because these take a while to turn on. Like if you had a cheap pump that wasn't ECM, or there's other different setups, you would want the 4-wire. That way you're not running, because some of those pumps, they run at 1 speed and it's not good to deadhead them like that. But this one's okay to do that. So that's the difference between 2-wire and 4-wire. There is a 3-wire too, but it's kind of an in-between thing. It's like a hybrid between the two of them. There's no need to really explain those. The most common ones are 2 and 4-wire. But you can see right now I have 2 zones that are activated. My second floor bath is activated and Caden's room is activated right now. So this has been heating really good. It's below freezing outside right now, and this really does the job really good, and it's super efficient. I'll show you the numbers in a minute here, but just to go back over the basics, every floor has radiant heat and they're all zoned into different rooms, and when this calls for heat, it just turns on the pump, which is super efficient. It doesn't have to turn on this system every time. It just takes water out of that tank. So to give you an idea what's going on, this is the program. This is called Symphony, and I think it's made by Water Furnace. And so it tells you all the different things, like the loop coming in is 47.5 degrees. That's the pond loop that's coming in. That's the temperature of it. Leaving the geothermal unit into the tank is 94 degrees. This shows you the power consumption. So right now we're using 3,300 watts, but that's not actually correct because my loop pump is set at 472 watts, which it's not actually that much right now. Right now it's actually about 150 watts. So you can pretty much subtract 300 watts from that. This one is set, and that's pretty close to what it is. That doesn't change. The compressor senses how many watts that's taking, so that's changing all the time, so that's correct. Auxiliary heat, I don't have that, and I won't need that. But basically I'm using 3,000 watts right now, and I'm pretty sure that the more the system runs, especially when it gets colder, that's going to go up a little bit. But I would say that it's not going to ever get above 4,000 watts. Probably be quite a bit less than that. I haven't seen it quite that high yet. But I've been running this for a couple weeks, and it's been really, really efficient. Let me show you. See, you can go to the energy use. So far I've used 125 kilowatt hours, and like I said, that's not even correct because that 300 watts difference in the pumps brings this down. I don't know the calculations, but it's probably somewhere around 110 or 115 kilowatt hours if we were to subtract that out of there. So, but let's just say it's 125, even though it's not. I've been running it for 12 days now. So if you take 125 divided by 12, that is 10.5 kilowatts a day. And right now we're paying about 22 cents per kilowatt hour. So that's running me roughly 2.25 a day. So if you times that by 30, that's $68 a month. Now that is heating my hot water too. Not just heating my house, but heating my hot water. So that's really good. Now, it's the beginning of the heating season right now, so that number is going to go up. But it's been pretty cold. It's been about what an average winter temperature is, in the 30s and in the 40s during the day. So you could say in the middle of January it's definitely going to be colder than right now. But let's just say it is, and let's just say the loop gets a little bit colder and you have to run everything a little bit longer. It's windier, it's less sun, whatever the case may be. I highly doubt that I'll ever reach over $100 a month. And remember, that's my domestic hot water too. That's not just heating. So that's really good when you consider comparing it to anything else. There's nothing else that even comes close unless you use like solar collectors and I guess you could use solar panels and use regular electric heat too, I guess, but this is like, you could do that with this too to make it super efficient as well, so you really can't compare that. So it even has a little calculator here where you can click on this, and I have it at 22 cents a kilowatt hour. So if you apply that, that's so that's how much it's cost me to run this for the last 12 days. So that should calculate out to the same number. So if you do 2761 divided by 12, that's about, yeah, about 2.25 a day. So like I said, that's like crazy efficient. So in my basement here, I kept the heat off for a while today, but actually it doesn't even need it. I have it set on 66 and it's 68 in here right now, and the heat hasn't even turned on today at all. But I just want to show you some thermal imaging here of what's going on with the radiant heat. So let's just crank this up a little bit so it turns on. So now you'll see that just turned on zone 6. So now these 3 actuators will open. It takes, I don't know, 2 or 3 minutes probably for them to fully open. And this is what they look like when they're open. So it's flowing at 0.8 gallons per minute on that one, and almost 1 gallon per minute on that one. So once that opens up and runs for a little bit, we're going to circle back and I'm going to show you what's going on in the floor with the thermal imager. So you can see nothing is really going on the floor yet, but I just turned it on, and actually I don't even think the thermal actuator's opened yet. One has. So we will start to see heat. Actually, you can see it right in that pipe right there. See how there's heat on that, just one pipe right there, and these ones are already going. But watch, another one's going to open any second now, and you'll see the heat going through the pipe. This thermal imager is super sensitive, so 0.1 degree difference and you'll see it on here. Those are the 3 that should open up. I don't know why they don't open up exactly at the same time, but you can see that one's going now too. Look at that. So now, look at that one. Starting to heat up. And the only reason there's a blank spot right there is because it's behind another pipe. So you see those go right into the floor there, and then you'll start to see the floor heat up. You'll see the coils in the floor. So there goes the 3rd one. You can see how quickly the heat shows up on here, and that's only 90 degrees on here. So that's not even that warm. Running this system at 90 degrees is super efficient, because a lot of times when you do staple up systems in a house, like with a wood floor or something, you have to crank it way up to like 110, even 120 sometimes, just to get the heat out of it. But this concrete slab, this geothermal system, 90 degrees all day, it's fine. And the lower you can run that temperature, the better, the more efficient the system runs, because the hotter that system has to run, the less efficient it gets. And they do have another system that's meant for like baseboard heat and radiators and stuff, that's called the OptiHeat, and that's meant to go up to higher temperatures, I think like 140, 150 maybe. This one's meant for about 130, that's about the most you can get out of it. So these tanks are very well insulated. I know that this one on the left has 2 inches of closed cell foam in it, and the one on the right, I'm pretty sure it has somewhere around that 1.5 to 2 inches of closed cell foam. So you can see they don't leak heat at all. The only place that has any heat is where the pipes come out, which I still need to insulate that. But the tank itself, like even that is just a TMP valve right there, which I could insulate. I will have to eventually, because it'll sweat otherwise when I'm cooling. But the tank itself, just, it's not leaking any heat. Same with this one. So that's really good, because if these tanks are sitting for a while not getting used, you don't want to have to keep heating them because they're losing heat. So right now the only heat loss out of these tanks, if they're on standby, is these fittings right here. This flow center right here is insulated too because that's got the pond loop temperature in it. So it's, 47 degrees or whatever right now. You can start to see loops in the floor, which is kind of nice too, because if you need to put like a tap con in the floor or something, you just turn the heat on for a little while and then you can see. So you can see those 3 loops, they come out right there and they go this way, and then that's the first zone that turned on, so that's a little hotter than everything else, but you can still start to see this zone here, and then there's this zone over here too. I keep saying zone, but it's not a zone, it's a loop, because it's all in one zone. But it's kind of neat because if you really need to see where it is, it shows up a lot better once it's heated up more. Because this has only been running for 10 minutes now. But for 10 minutes you wouldn't think you'd be able to see any heat at all coming out of the floor, but look at these. These have been running for like 12 minutes because it was the first loop to turn on. But anyways, you get the point. This is a really efficient system and it's comfortable too. So I'd like to go over the cost of this whole system, but I don't really know because the part that I have to pay Eric for isn't figured out yet. So I can't really speak on how much that's going to be. I have a rough idea. If I could throw a really wild number out there right now, between all the stuff that I bought, all the stuff that he bought, and the labor that he has into it, just all the moving pieces together, I think we're around 20K. Could be a little bit more, could be a little bit less. Maybe I'm way off, I'm not totally sure, but I'm pretty sure we're about 20K right now with this whole system. Now that's obviously with me doing a lot of work. I tried to do as much as I could with this whole thing, and I did a lot of the work outside. So there's a lot of stuff that I did, whereas if you were just a customer that was trying to get this system installed, you'd have to hire somebody for a lot of this stuff, so it would obviously drive up the cost a lot. You'd probably be more like 35K or somewhere in that range. But that 20K that I think is what the number is for me, that does not include anything for rebates and credits. So I'm going to get $8,000 back from the utility company, so that brings it down to 12K, give or take. And then I have a big tax break too, because I get a 30% tax rebate when I go to do my taxes. I can use that credit. Now that credit doesn't go below 0, so say you don't owe that much to the government and then you have $10,000 coming back from this system, you don't get $10,000, you would just go to 0, and then the next year they would deduct the rest of it, or if the next year is low income too, then they deduct the next year. So, and I guess deduct is not the right word, but my point is that you never get money back from them, you just don't owe them money. And then whatever you don't use carries over up to like, I think 10 years, or maybe it's even longer than that. So for me, if I'm paying, let's just say between 12 and 15K after the utility rebates, then the tax rebates on top of that, you can't get any kind of other system for that kind of money. Like if you had central air, you would not be able to touch that for this kind of money. And the reason is because of that utility rebate. If it wasn't for that, this system would be quite a bit more expensive, but $8,000 off the whole system, that's quite a chunk to be taken off, plus the tax credits. So my ROI on this system is probably only going to be 5 years or less, and then after that I'm making money on the system. And when I get my solar, I will be not only net zero, but with this system and how tight the house is, I'm going to be net positive. So I'm going to be making money on the utilities to live here, not subtracting it. And it adds resale value to your house if you ever want to sell it too. which in my case, I'm probably not interested in that, but I'm just saying it does help you out in other ways too. So like I said, obviously this system is much more complicated because of the air conditioning. You could put some mini splits in for the air conditioning to make it a lot easier. Probably would cost the same, but I just have been dreaming of this system for years to use with cooling and the fan coils and everything. So that's just what I had my mind set on. And it's something that not a lot of people do, so there's not a lot of products out there for it. There's not a lot of information about it. But Eric has done it plenty of times, so he was able to really help me with that. And he was able to really help me with this domestic water too, which is really nice. Just having the three things, just having those three things, the heating with the radiant heat, and then the domestic water, and then the air conditioning with the fan coils, those three things running on this system is like top of the line. And the unit is top of the line too. I don't think they make any better units than water furnace. That is like the top of the line. So I'm really happy with this system the way it is. I'm actually just super excited. I just can't wait until I can start seeing some numbers when it's really cold. I want to see like how many kilowatt hours I'm using and stuff, and then I want to do a cost comparison at the end of the year and see per month how much it costs and everything like that. And it's something that's really exciting to me. I can't wait. And right now I have a generator that could probably run this system, but it would probably be maxed out. So I'm gonna probably get like a 10 kW generator, and then that way if we lose power for a couple days, I can still have hot water, I can still have heat, and still have water running too from the well pump. So I do want to give a shout out to Eric, and his company name is Natural Energy Solutions, and he's got his own channel. So if you guys want to check that out, I'll leave a link in the description. He's had a hard time finding the time to make videos. He's got tons of them ready to edit and make. He's got tons of footage from all kinds of jobs. He just hasn't had a lot of time to edit them. But if you guys go on his channel and leave him some comments and say, hey, get your butt in gear and get these videos edited, it would probably encourage him to get going with that. I know he's got one that's coming out like right now or in the next day or two or something. So if you want to learn more about this stuff, and he also does solar as well as solar collectors, and he does turbines, like wind power, and you know, he does the geothermal water to air. He doesn't really mess with air to air, but he does do some work on like mini splits and stuff like that. But he's basically like a genius, honestly, when it comes time to this stuff. So definitely check out his channel, and let's see if we can get his channel going a little bit more. Let's see if we can get some more subscribers sent his way, and then he'll be encouraged to make more videos, and then you guys can learn more stuff about this, because it's really few and far between as far as getting information on these kind of systems, especially water to water. When you go online to research geothermal systems, you either come up with a video that's like 15 years old and it's like recorded off of VHS, or just a short video with nothing really being explained. So he's kind of like me, where he gets really technical into things. So if you want to check out his channel and just leave him a comment and tell him that you're interested in getting some of the videos that he's got already recorded, uploaded on the YouTube. But that's it for this video, guys, and we will circle back around to this later on this winter, and I'll just, you know, maybe I'll mention it in another video. I'll mention how much energy has been used, how it's been going, if I've been maintaining with just 90-degree water going into the loops, or if I had to raise it a little bit. We'll see how it goes. And then also I want to let you know how it goes with the cooling too, which is, you know, 6 months away or so, but we'll definitely go back to that, and I'll mention it in other videos, because I know it's really interesting to me, so I'm sure you guys will be interested in it too. So anyways, that's it for this video, guys, and I will catch you on the next one.